business calc. And it says 4.6 notes. Okay, so I kind of skipped a little bit, which is fine. It's not going to hurt us. Okay, so actual versus estimated. We're less than halfway down the page. Example 1 says, suppose the total revenue generated by the sale of a product is given by R at X. So we have some function. Remember, R at X is going to mean the same thing as F. 25x minus 0.05x squared. Okay? So that's the first equation. And then they say, hey, find us R50. Which means I'm going to take the 50 and we're just going to plug it in. So I'm going to jump over to my graphing calculator, see how I do. So 25 times 50 minus 0.05 times 50 squared. And that comes out to 1125. Okay? So 1125 is what this would have resulted in as an answer. So basically this is called a revenue function. A business might use something like this. So this basically means if this particular place knew that they had these items for sale, built into this revenue is like the cost of what the item would take to sell. So if we were to sell 50 of the items, your revenue would be $1,125 is really what you're looking at there. It's pretty straightforward. And then they say we want to find R51. Okay, so we're just talking about one more than what we had done. So I'm going to go back to my graphing calculator. And if you ever plug in something big into your thing, oops, second quit. If you go second enter, it brings back up your original function and allows you to just use your arrow over. So then this is going to tell us that we're at 1144.95. So you made a little bit more on selling one more item. Okay, and it's taking into account, costs and things like that. So 1144.95. Okay, so granted, this function itself would form some sort of parabola that looks like this. Okay, the reason it opens upside down is it's a negative here. That's why it opened upside down. So basically we found a cost here and a cost here. And the reason I know that we're still going up on our parabola is because this value is a smaller value than this value. Okay. Then it says find the marginal revenue at x equals 50. Tell us what it predicts. Okay. So if you want to look for the marginal revenue, we're going to do the first derivative of r. So r prime. So if I take the derivative of 25x, what should I get? If I just take derivative of 25x, what do I get? Anybody? 25? Because that's raised to the first. Bring down the 1. 1 times 25. X raised to the 0 power is just 1, so 25 times 1. Okay, minus the derivative of this, so bring that down front. So you get 2 times 0.05. X, subtract 1 from it. And so right here, this is your marginal revenue. And if we wanted to find that at 50, what we do is we'll just take r prime at 50. We'll plug that in. And this is finding us basically the instantaneous slope of our function. So again, just on the calculator, 25 minus 2.05. Is that right? Did I do that right? 2 times 0.05. Sorry about that. That should be a times. Second insert times. and then that was times 50. So that's going to come out to 20, okay? So this would result R prime of 50 comes out to be exactly 20. Go away, I don't want that box. Okay, so this becomes the slope at exactly 50, okay? And then we already talked about what E is. What is the difference between R51 minus R50? Well, it's 1144.95 minus 1125.00. Just do simple subtraction. So that's 0.95. That's a 9. That's a 1. So 1995. So basically, at that particular level, the increase from one to the next means you're looking at making an extra $19.95. Okay, that's not always the same. And the reason it's not always the same is on a parabola that does this, depending upon where you're on the graph, if I was here to here, this has, a pretty steep slope. Whereas if I went from, like, say, here to here, the slope is not as steep. And then there actually becomes a scenario with this where you start doing slopes over here. So what happens is, think about it, if you had a company and you knew like the ideal amount of items that you could sell is 100 of these particular items. After that, your company is actually losing money because things that go along with your revenue is the cost to warehouse something. So let's talk about like a car lot. So prior to COVID, you drove by any major car dealership, they had cars everywhere, right? So like, let's say you went over here to Arapahoe Road, went to the, I don't know, I'm trying to think of a dealership over there. Say a Honda dealership over there. Prior to COVID, you drove up and they had cars pretty much everywhere. Every now and then you might have an open spot. Doesn't mean that they didn't have that car. That car might have been on a test drive. Unfortunately now, because demand was high while inventory was low, a lot of times you drive up to a car dealership and you have very few cars to select from. And that's just kind of the name of the game. But a car dealership would sit there and say, okay, we own all this land, but if we don't have enough spaces for all of our cars, and let's say there's some code that they have to follow to say, you can only have the number of cars as you have as parking spaces on your lot. As soon as you go above that, then the city of Centennial or whatever says, hey, too many cars. Now you have something that's you get a little bit of a fine. It's like a tax or something. Okay, and I'm just making that up as an arbitrary thought. Example 2 says if the demand of the product is given by this equation, where the number of P units is the price per unit, find the marginal revenue at X equals 40. So at X equals 40, all I'm going to do is I'm going to take 40 and plug it in. Now, why can I not necessarily do the derivative of this one to get the marginal revenue? Well, one, it's a cost product, but you can't do the derivative of it because our original was raised to the first power. If I take the derivative, I just wind up with negative 0.02. Okay, so it's not necessarily going to work. So if we do the math here, I'm going to get 16 minus 0.02 times 40. So 2 times 4 is 80. Move the decimal, so that's 0.8. So that becomes 15.2. Okay? And then if we said, hey, what about if we had R41 versus R40? Well, this right here is basically R40. And if we found R41 is doing the same thing, that's going to be 16 minus 0.02 times 41. And then just do the math to it. 2 times 41 is 82, 2 decimals, so minus 0.82. So 16 minus 0.82. So that's going to be a little bit less. That comes out to 15.18. Okay, so there's a difference in price here when you sell a certain amount more. What's the difference between the two? You're talking about, R41 minus R40 would come out to be, R41 was 15.18. If I subtract 15.2 from that, we get a negative number. In this case, we get a negative 0.12. Okay, so there definitely becomes a break-even point. There becomes a point where you start making profit. There becomes a point where you might be housing too much, where you're actually losing money. There are certain states throughout the United States that have very large warehouses of inventory for stores. One of those states is the state of Nevada, where Las Vegas is. If you've ever driven across I-80 from Elko to Reno, or if you've ever taken I-95 or I-93 in through Vegas, those are basically the major roads, and then you actually have Highway 50 as well. If you go on any of those roads, as long as there's railroad tracks along that route, all of a sudden you're driving and all of a sudden you see these huge warehouses, like bigger than Costco, okay? And you just have them lined up and you're like, what in the heck's out here? Nevada doesn't have a tax on an overflow inventory. Other states do. So a lot of stores would store excess inventory in certain states that don't have an inventory tax. So, when you are in business, you're in business to make money, right? That's the name of the game. Someone's not going to say, hey, I'm going to open a business. I hope we be bankrupt in a day. No. I hope to open a business. I hope to make a lot of money. And I hope to have lots of happy employees. Okay? Example 3 says the total profit in thousands of dollars for a product is given as P at X equals 20 root X plus 1 minus 2X. Find the marginal profit. Okay? Marginal profit at X equals 15. So what I'm going to do is I'm just going to go P at 15 equals 20 root 15 plus 1 minus 2 times 15. That's going to give me 20 root 16 minus 30. Root 16 is 4. So this becomes 80 minus 30, which is just 50. Okay, so that would be our marginal profit in this case, where the minus 2x might be accounting for certain taxes and things like that. If you were to find the difference between P at 16 and P at 15, there's definitely a slope that takes place. So if I found P at 16, and I use this, I'd get 20 root 17 minus 2 times 17. This is definitely something for a calculator. Go here, go here. So 20 root 17. Root 17, close parentheses, enter. And then I'm going to go minus what? Minus 32. So that becomes 50.46. So P at 16 is 50.46. Okay, so you're making a little bit more profit, and some people are like, what's the big deal of making 46 cents? Well, 46 cents, if you use over 1 million products, items, that's a lot of money. Okay, so what I'd like us to work on, we're going to start this today. I will not check this off on Monday, but what I'd like us to do is worksheet 4.6. And I'd like you to do, let's just do 1 through 7 odd. We'll do that. I won't check that off on Monday. I'll go over it and then we'll assign the rest. So what's today's date? Today is the 4th. So I gave 1 through 7 odd. That's all I have for you for today. Sound like a deal?